Good morning. Today we are going to work through some additional problems that involve adding and subtracting rational expressions. Yesterday, Thursday, February 18th, you should have been introduced to this concept. Today, which is Friday, February 19th, it's going to be an asynchronous day where you watch through this video lesson additional problems around this concept, and then you're going to work through some more problems independently. Okay? So, again, the title, if you are taking notes while you're viewing the video lesson, the title is 4.3 Adding and Subtracting Rational Expressions. This is day 2, February 19th. So, you should have gone through the first 10-ish slides yesterday. And so I'm going to pick up on this problem here, okay? We're going to start with 3 over x plus 1 minus x over x minus 1. The first thing that I'm going to identify are the restrictions on x. What can't x be? What are those values of x that would make the denominator or denominators 0? So in this case, just looking at my denominators, I know x cannot equal -1 or +1, okay? Those are my two restrictions. In order to add fractions, I need to have a common denominator. So my common denominator here is going to include both x plus 1 and x minus 1. So I'm going to multiply on the left-hand side by x minus 1 in the denominator and in the numerator. And on the right-hand side, I'm going to multiply by x plus 1 in the denominator and the numerator. I'm going to go ahead and carry through and understand that my denominator is now x minus 1 times x plus 1. I'm going to distribute into the top, which is going to give me 3x minus 3, and then minus x squared minus x. Okay. I'm going to combine like terms in the numerator, and that leaves me with negative x squared plus 2x minus 3. Okay. Now, I'm going to go one step further to see if I can factor the top. If I first divide everything by a -1, that would give me x squared minus 2x plus 3. And I know there are not two numbers that multiply to give you a +3, add to give you a -2. It's not possible. So there's no way to factor the numerator. I'm just going to go ahead and carry through my denominator. I can either FOIL it out or leave it in factored form. I'm going to choose to leave it in factored form. X minus 1 times x plus 1. Final answer is here. Okay, next example. The first thing I'm going to do with this problem is factor both of my denominators. I want to factor both of my denominators so that I can determine what the least common denominator would be. So my left-hand denominator is a difference of two perfect squares, x plus 2 times x minus 2. My right-hand side denominator, two numbers that multiplied to give us +4, add to give us a b value of 4, would be x plus 2 times x plus 2. Now, we understand that the denominators need to match in order to add or subtract fractions. So the left-hand denominator has one x plus 2 and an x minus 2. The right-hand denominator has two x plus 2s. So what I need to have on the left is an additional x plus 2 in the denominator and numerator. And on the right, I'm going to need an x minus 2. Okay, so now my least common denominator includes x plus 2 squared, or I can just write it additionally next to it, times x minus 2. At the top, I'm going to do the distribution. 2 gets distributed into this binomial. X gets distributed here, which is going to give us 2x plus 4 plus x squared minus 2x. So what's going to happen when I combine like terms is our numerator is going to become just x squared plus 4 because the 2x and the negative 2x cancel. And the denominator is going to be x plus 2 times x plus 2 times x minus 2. I am not able to factor the numerator. X squared plus 4 is prime. It's not factorable. Final answer is here. Okay. Next problem. My denominator on the left is a singular x. My denominator on the right is an x squared minus 3. X squared minus 3 is not factorable. Obviously, x is not factorable. So my least common denominator is going to involve us multiplying on the left, bottom and top, by x squared minus 3. And on the right, multiplying by x in the numerator and the denominator, which gives us an LCD of x times x squared minus 3. I distribute in the top, which obviously a 1 distributed in gives us x squared minus 3 back, plus 2x squared, okay, which when I combine like terms in the numerator gives us 3x squared minus 3. Now, I can factor additionally in the top. It's not going to help us at all as far as canceling. So if I pulled out a 3, I would have x squared minus 1, which would then be 3 times x plus 1 times x minus 1. Let me erase that. Moved over a little bit. 3 times x plus 1, x minus 1. That doesn't help us at all, bringing through our denominator x parentheses x squared minus 3. So you could factor the top, or you can go ahead and leave it here because factoring the numerator would not help us to cancel anything in common. Okay, final answer is in yellow. Okay, next problem. The left-hand denominator does not factor. The right-hand denominator is factorable. Pull out an x. On the inside, you would have x minus 3. So now I look and I see that both denominators have an x, but the right-hand side has an x minus 3 additionally. So what I know I need to then do is multiply by x minus 3 at the bottom and the top so that I have the least common denominator. Our least common denominator carries through as x parentheses x minus 3. In the numerator, I'm going to distribute the 2 here and here, which is going to give us 2x minus 6 minus 3 from this negative 3 here. Okay, distributed there. My numerator now becomes 2x minus 9 over x parentheses x minus 3. I can leave it factored, or I could distribute in the denominator x squared minus 3x. Either way works. Final answer here. Okay, let's keep going. Next problem. I have 2 completely different binomial denominators. I cannot factor either. They're binomials that are not factorable. So I'm going to multiply the left-hand numerator and denominator by x minus 3. I'm going to multiply the right hand by x plus 2, bottom and top. I know my denominator now is x minus 3 times x plus 2. That's my least common denominator. At the top, I'm going to distribute the x here and here. I'm going to distribute the 4 here and here, which gives us x squared minus 3x plus 4x plus 8. Final answer, when we combine like terms, is x squared plus x plus 8. I cannot factor that, so I'm going to leave it over x minus 3 times x plus 2. Now, again, you could distribute FOIL at the denominator and leave it as a quadratic. That's fine. Or you can leave it in factored form. Either way is acceptable. Final answer is here. Okay, next example. On the left-hand side, I am able to factor. It's a difference of two perfect squares, x minus 3 times x plus 3. On the right, I can't factor, it's just x squared. Okay, knowing and seeing this, I know the left-hand side needs an x squared to be multiplied at the bottom and the top for the least common denominator. The right-hand side needs x minus 3 times x plus 3. I can either choose to write that as two factors, or I know it's going to be x squared minus 9. That is what x minus 3 times x plus 3 is. So I'm going to leave it like that, which is going to save us, when we distribute at the top, it's going to save us time for that distribution piece. So our denominator at the bottom is, we can either write it as x squared parentheses x minus 3 parentheses x plus 3, or x squared parentheses x squared minus 9. Either way works. I'm just going to go ahead and write it as a factored. Okay. At the top, we're going to do the distribution here, here, and here, which is going to give us 2x squared minus 3x squared plus 27. Combine like terms, and our numerator gives us negative x squared plus 27 over x squared parentheses x minus 3 parentheses x plus 3. And I can't do anything further because the top is not factorable. I can pull out a -1, but it's not going to help us at all. Okay. Keep going. Ooh, this is a nice one. I just have 3 and 8 in the denominator. 3 and 8. What do I know? 3 and 8 both go into LCD. I know they both go into 24. So in order to get 24, I'm going to multiply the left-hand denominator and numerator by 8. I'm going to multiply the right hand by 3, which is going to give us a common denominator of 24, 8 times 3. And then at the top, I have 8 times 5 is 40x minus 7x times 3, which is 21x, which is going to give us 19x over 24. I can't simplify. Final answer is here. Okay, next example. Left-hand denominator, I'm going to factor. I can pull out an LCD of 4, and on the inside would be n plus 9. On the right-hand denominator is already n plus 9. So what I recognize is the right-hand side needs a denominator addition of 4. Not addition, you're not adding anything, but I know I need to multiply by 4 at the bottom and at the top. Our common denominator is then 4 parentheses n plus 9. At the top, left-hand side, I did nothing to. N squared plus 11n plus 10 plus 4 times 2 is 8. At the top, I have n squared plus 11n plus 18 over 4 parentheses n plus 9. Now, this one's a little bit of an anomaly. I can factor the top this time. Two numbers that multiply to give us a positive 18, add to give us 11, would be n plus 9 times n plus 2, which doing this then results in us being able to cancel out a common factor in the numerator and denominator. So our final simplified answer results in n plus 2 over 4. Final answer is here. Okay. And number 8. Did we do this one already? This one looks like, let me go back up really quick. Feels like that's the first one we did. Let me check real quick. Sorry about that. 3 over x plus 1 minus x over x minus 1. Is that what that is? Let's see. Oh, this one's plus. Tricked us. Looked very similar. Operations different. That's fine. Okay. Common denominator. LCD that I need is going to be left-hand side needs to multiply by x minus 1, bottom and top. Right-hand side needs to be multiplied by x plus 1, numerator and denominator. Therefore, our common denominator is x minus 1 times x plus 1. Our numerator, distribute here and here, distribute here and here. That gives us 3x minus 3 plus x squared plus 1x. Combine like terms at the top, we get x squared plus 4x minus 3. Notice when I combine like terms, I place my answer in standard form. That's best mathematical practice. Okay? That is not factorable. There's nothing else I can do with that. Bottom denominator is going to be x minus 1 times x plus 1. Final answer is here. Okay? Left-hand denominator is not factorable. Right-hand denominator is a difference of two perfect squares. A minus 2 times a plus 2. That indicates to me I need to multiply by an a minus 2 on the left-hand side only. I'm going to multiply a minus 2 in the denominator and in the numerator. My carried through common LCD, least common denominator, is a minus 2 times a plus 2. At the top, I'm going to distribute here and here, which is going to give us a squared minus 2a. Then I have to be really careful. I have a minus sign. I need to distribute this negative here and here. You want to be cognizant of that, of doing that, okay? Which gives us a negative a minus 10, which when we combine like terms gives us a squared minus 3a minus 10. Now, that is factorable. There are two numbers that multiply to give us a negative 10, add to give us a negative 3. We're going to use negative 5 and positive 2. Okay, so we want to factor that top. And when we factor again, we just said we're going to use a minus 5, a plus 2. Now, when I carry through the denominator, a minus 2, a plus 2, I immediately recognize I can cancel out a common factor in the numerator and the denominator, which leaves us with our final simplified answer of a minus 5 over a minus 2. Final answer is here. Okay, I believe we have one more example, and hopefully this was helpful. Whew, this is a whopper. This incorporates multiple skills that we've worked through the past few days. Okay, let's focus on simply just the numerator at first. Okay, focus just the numerator. At the top, I'm going to multiply by x plus 1, bottom and top on the right. I'm going to multiply by x minus 1, bottom and top on the left. Okay, so carried through, my denominator is going to be x minus 1 times x plus 1. I'm going to distribute the x here and here, which is going to be x squared minus 1x. Distribute the negative 1 here and here. Remember, that's a negative 1 because of that minus sign. So negative 1x minus 1, which gives us combined like terms at the top, x squared minus 2x minus 1 over x minus 1 times x plus 1. Okay, now we got to worry about the bottom. I'm going to use a different color. At the bottom, this 2 is really over a 1. In order to combine like terms, I need a LCD. So I'm going to multiply by x plus 1 at the bottom and at the top, which carries through my LCD. So I'm going to use my first fraction bar, and then I'm going to make my fraction at the bottom. My LCD is just going to simply be that x plus 1. And I'm going to distribute the 2 here and here, which is going to give us 1 plus 2x plus 2. Okay, combine like terms, and I have 2x plus 3 over x plus 1. Now, we're in a predicament. We have a fraction in the numerator, a fraction in the denominator. When that happens, you drop the top, the entire top fraction, and multiply by the reciprocal of the fraction at the bottom. What does that look like? Watch as follows. I'm going to drop the top. X squared minus 2x minus 1 over x minus 1 times x plus 1. I'm going to change the sign to multiplication, and I'm going to multiply by the reciprocal of the denominator, which is going to flip it to x plus 1 over 2x plus 3. Now I have a multiplication of rational expressions, okay? The top left numerator cannot be factored at all. Nothing else can be factored. I can cancel here and here, which leaves us with our simplest form answer as x squared minus 2x minus 1 over x minus 1 times 2x plus 3. Okay, final answer is here. Hopefully this helps. One of the benefits of watching the video lesson is that you can pause, you can rewind, or you can fast forward, okay? These were all excellent examples to help you with the skill of adding and subtracting rational expressions.